Good afternoon, everybody. Just thought I'd show you one of these local blacksmith kind of jobs that comes through the door. So this is a piece of 7/8 stainless bar. I forget, 80 some inches long. Anyways, here's my very crude sketch of what it's turning into. So this, what these are, is there's a craft shop sewing place here in Allegan called the Sassy Olive. And this is a bar that supports their reams of cloth on their automated cloth cutting machine. So they want some more of them made. Now the factory one, I'm guessing the machine's made in China from the looks of it. Anyways, the factory bars are 20 millimeters in diameter, and 7/8 is like 22 something, I forget what. But anyhow, they had decided that was acceptable because 20 millimeter bar was way too expensive to get compared to 7/8. So anyways, I've gone down there, taken some dimensions. I just got back from measuring this up. So I got to set up and do some machining. But here's the issue. That thing is going to be sticking through the headstock. Like you can see, I've slid the tailstock ahead on the Colchester lathe. It's going to be way out here off the end. And I don't know if any of you, I'm sure some of you have, but some of you, this is going to be news to you. If you stick a bar way through your headstock like that, I have personally witnessed a bar about identical this size in a lathe. I didn't do it, but get spun up, and about the time it hit speed, it started doing harmonics and whipping and bending itself in a perfect 90 degree and then coming around and just beating the shiznits out of everything within reach. So before I even start, I am going to machine myself up a plug that pops into the tail end of my spindle, and that basically cinches this thing down to where it can't start going berserk and go crazy. But even at that, I'm going to warn you that you don't be turning fast when you've got relatively small diameter shafts way out the end, because you can get some crazy harmonics going, and you're over here busy machining on this end, and all of a sudden all hell unleashes itself on the other end of the lathe. So anyway, that's what we're getting ready to do here. So I just dug out, got all kinds of junk in here. I've got half the contents of the Wander Lodge in here, but yeah, there's the breakfast nook, or half of it sitting there. So I got this hunk of aluminum bar stock. I'm going to nip me a chunk of that off, and then we'll go to it and machine it up to make the plug that I need for this. So anyways, I'll bring you guys back when I get machining. Okay. See if this goes on here. Oh yeah. That'll work. That, I'm happy to have a sliding fit, because that'll let me slide the bar back and forth through it. That's what I expected to get by reaming it, because these bars are almost always slightly undersized, with the idea that you're going to slip them through a stock size bearing. So that'll be just beautiful. I think we can start getting set up to do the actual machining job we're after here. Alright, so we've got this chucked in the lathe. I've got it as short as I could get and still comfortably come do the dimensions. I got to run a taper, clean the end off, and put a groove in there. And then back here, you can see I've got, I'm going to tap this in a little bit further now. I'm leaving just enough of a groove in there to get behind it, pry it out if I need to. So here's what I want to show you. See that? How she wants to get a nice bounce to it, sticking out the back end. That is what we got to watch for when we get running, because if you get the harmonics just right, even that is enough hanging out there to either go berserk and blow itself up or start walking this out. So I'm going to show you, we're going to do a little trick to that because I don't want that walking itself out either. So, take a hike over here, dig into the junk drawer. Let's see here. There we are, there's what I'm looking for. It's about right. So, we're gonna go cure this thing. At least this way. The fancy schmancy spacer can't walk off the shaft. Sorry for all the jerking around. I'm trying to get my screwdriver configured with one hand. It's not that much fun. Need to get my wiggles, my cameraman wiggles back. Alright. Alright. There. Just a little extra insurance to keep that spacer from coming out of there. And now we're ready to go to cutting. $700, $800, $900. There's an inch. And we go 1, 2, 3, 4, and look at the number, 0.96. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 5, and there is 6. So this, because we're backing up, all the slap will be forward. So what I'll do is bump up against it here, and then tighten the set screw. Because otherwise, if you don't take the backlash out of it, you won't be getting accurate dimensions. Now, I don't look right. Somewhere the math is wrong. Oh no, I take that back. This is why you verify. It does look a lot like 38 millimeters. Okay, it looked long enough. Kiss the shaft. And 0 our dial. Put plug to it. So, this notch is finished. It came out just gorgeous. I have to cut a couple of flats in here yet. So this end has to get taper cut on it, notch cut here, and then flat all the way to the end. Alright, so I've got the flats milled on the far end of both shafts, and what I need to do now is I need to cut a pair of notches in here, and those have to be indexed with the ones on the other end. So this is where a digital level is a really awesome tool. Because I can set this thing up here, and then tell it that I want to 0, which I just did, because Bridgeport is not precision level, but the digital level, I think this one can handle up to 20 degrees, 15 or 20 degrees out of level. So now it is zeroed right there, and I can carry it down to the other end now. Alright, come around down to this end now. Agrees with what my micrometer was telling me, which is that the shaft is twisted that way a little bit. So set this off to the side. Come back to that end. .142. All right. zero the dial on the knee. And we're going to try just bring her up the 100. 42. Lock the knee. We try just taking her all in one pass. It's not that deep of a cut. Big setup blocks, or step blocks off from the boring mill. Alright, that'll work. It's amazing how repeatable these things are. I had this, shut it off, had it in the box, took it back out, turned it on, and it's still dead nuts on zero from where I zeroed it before. Down to this end we go. Says we are quite a bit high to the back. Point one, we're going to roll with that. I got it closer the other way, but I did it by coming at it from further away than this, so I'm basically lucked out what it boils down to. Alright, let's fire this up. So a reamed fit just ended up being too tight. I decided that it was going to fight them, so we're actually giving it some clearance. For what these do, they just got a little lock screw that goes in there. Decided they were going to hate me if we didn't open these up a little bit, so anyway. reason I don't power tap in all the way is because this tap is barely long enough. I have to bottom the tap out. And then in aluminum, it's really easy to pull the top thread out when you're coming back out. So on a low production item like this, where I'm only making a couple, I just start the tap and finish it by hand. Alright, well, here is the finished product. This is the spacers that I was just making. Those are to keep the roll of cloth centered where they want it. So they needed 2 of those because the original rods that we're replicating were actually 20 millimeters. And so the existing spacers they've got wouldn't fit on these bars. So anyway, that's it. These are ready to get dropped off to the customer. I had... about 7.5 hours into this whole project. Fair amount of that was because I had to, screw around and make that spacer you can see sitting on the back of the lathe for the end of the tailstock. I had an hour and a half into screwing around, getting the material, cutting these off, boring them, that was added. So I guess if you took that all out of it, the actual bar manufacturing part of it is probably, I think here, probably about 5.5 hours start to finish, which seems to me like a lot, but then I take a step back and realize you got this taper you're setting up to cut, it's a lot of screwing around to get the dimensions on that, and then as you guys all saw, the horsing around in the Bridgeport to get that set of notches and that flat on that end all indexed to each other correctly is a lot of monkeying around with the level. So just as simple of a part as it is, it's a lot of screwing around. But anyways, we're going to drop these off, test fit them, and hopefully get on to the next job. Oh, alright, well, I went and dropped off that job, and then I thought I would just give you a little bit of a rundown on how that one actually came out. I mentioned a few numbers, but just for curiosity's sake, if anybody out there is wondering, so let me pull this up. I got thinking about my time in that thing, and realized that I wasn't given an accurate reflection of actual machining time. The reason is that included in that time is 2 trips down there to their shop. First one was to go pull dimensions and figure out how the thing worked, right? So that I knew what was critical dimensions and what wasn't. Like that thing had those tapers on the end. I had no idea what function those served. I had originally been told that those bars indexed between those. Well, then that proved to be totally false. Those were not important. They were just strictly given a little bit of a point so it'd slip through there easier. But anyway, so I told you I had 6 hours, I believe. I had 7.5 in the whole project. But anyway, I had 6 hours written down for machining the bars, but realistically, something close to, let's say at least 45 minutes to an hour of that is 2 trips down there. The first one was to go pull dimensions. I missed a dimension, which I would feel bad about, because I had to go back down there and check one more dimension, but it was at that trip that I figured out that their spacer sleeves would not fit these new bars, because I had originally asked about that, said, wait a minute, this material I've got that was delivered to me by the, this job was referred to me by another shop, and they supplied the material, and I mentioned early on in the video that the stuff they gave me was 7/8, and the original was 20 millimeters, so that 7/8 is, I don't know, something close to 22.5. And I'd asked about that, and they said, nope, they were assured it didn't matter. And so then, when I was down there, I asked them, like, do these spacers fit? And then that was the oh poop moment when, yeah, that's not going to fit. So even though it was my miss, me going back down there is what opened up for us to know, okay, we needed to make them some more parts to be able to make this all work together. So anyways, that said, actual machining time on those stainless rods from start to finish, somewhere 5.25 hours, and then, the hour and a half in the aluminum, that's get the bar out, cut the bar, face the bar, bore it, ream it, and then I wasted a little bit of time there because I was reaming them, hoping it was good. I say wasted. the first thing I tried didn't get me. I realized it wasn't a loose enough fit, so I had to go back in the lathe and then bore them out a little. So I probably used up 15 more minutes than what I technically would have if I'd just gone straight to drilling them and boring them. But anyways, you know, just it's a lot more monkeying around than you think with even something like that. 'Cause I bore them, then I had to get them over in the radial drill, get set up in the right location, drill it, tap it, pull that one out, put the other one in, drill it, tap it. So anyhow, long and short of it is, whole project 7.5 hours. Now, this is a good example of the kind of thing where, here a while back I mentioned some prices, and I had some guys really kicking me in the chops for, you know, I was charging too much and being too outrageous and all of that. So my normal shop rate here in the shop is $120 an hour. Now, I'm sure you can find a machine shop somewhere that's probably, I'd be surprised if there's any of them much under about 75, unless they're owned by some old retired, I say old retired, some guy that's old enough he ought to retire. Like my dad, I don't think ever got above $60 an hour right up to when he retired. He had been $40 an hour through my entire childhood, he had everything paid for, and he was happy with that, and he was making a living. The difference between that and me is I just dumped many thousands of dollars into buying the shop. I've dumped unbelievable amounts of time, quite a bit of money, but way more time into getting the machinery, fixing it up, getting it in this shop. I'm sorry, you cannot outfit a shop like this from scratch and set it up and make a living you can survive on $60 an hour anymore. Like, maybe you can somewhere where you're at. I cannot do it here in Michigan. So anyways, or for that matter, if I could, I would just quit and go get a job. I mean, seriously, like, right now, there are multiple places that would hire me on. The last place I was at that I had a job, I was salaried at, I think it was $67,000 a year. So, you know, I have to make at least that much, or I'm not going to be here. And that's what I've realized, is that I've got to make enough that I can justify being here when the phone rings. It's like right now, okay, that job's out the door. You've got to make enough when you do a job like that you're here, because if you're not here, then it doesn't matter how good of a deal you are. If you don't exist, then they got to go somewhere else and they're going to pay more. So, that said, the material for this job was $98.40. So, if I, and I didn't bill them for the aluminum, I had the bar stock on hand. It was 4 inches worth of 3-inch bar stock. If I just add it all up, it's $998. Now, I'm going to assume I had no involvement with the original drop-off of this part. I'm just going to say I doubt anybody, you know, they're in this cloth sewing industry. I'm assuming they have no idea what machine shop time costs, what machining in general costs, and I'm betting that's more money than they're expecting to spend. I'm just going to go based on, we'll say, my gut hunch. So I am not just sending them the bill. I'm going to go down, I'm going to discuss it with them, I'm going to explain the situation, and then I'm going to ask them, like, what were you expecting to spend? And to be perfectly honest with all of you, I really doubt we're going to bill them $998. I don't know where we'll end up. I got to get a feel for, maybe this is bad business, maybe it's good business, I don't know. I got to get a feel for, like, are they making a good living, right? Like, I don't want to be the straw that breaks the camel's back. And at this point, you know, honestly, it was kind of a cool project. I'll do anything like that. I'll do it practically for free once if that's what they need done. Now, that said, what I'll make clear to them is these ones, honestly, I'll make sure they get done for whatever they can comfortably afford. I mean, if they tell me, listen, we're scraping by, we can only afford $300, then $300 is what I'm going to do those parts for. But I'm going to tell them, like, hey, I enjoyed the project. This one's on me. But if they want more done, then it won't be as high as this set, because I already made that aluminum spacer. I'm going to hang on to it. So, I mean, but if they told me they wanted 2 more done identical to these, I'd probably tell them, yeah, you're talking $800. So, anyways, I wanted everybody to know, like, this is the kind of thing that actually goes on. There's the difference between what I theoretically charge and what I actually charge in the real world. And this is one of those where I don't think we're going to get anywhere near the hourly rate that I theoretically charge. And that's okay. Like, another local small business, I want to see them make it too. So that was it. I'll catch you guys on the next one.